The solution set for a linear inequality in two variables will be a section of the coordinate plane. Up here I've written graph 2x plus 3y is less than 6. That's a linear inequality in two variables. The boundary line is 2x plus 3y is equal to 6, and that shows us the cutoff point between where the solution set lies and where it doesn't lie. So I simply replace the inequality symbol with an equal sign, and now I want to graph this. So I'll let x be equal to 0, y equals 0, then x is equal to 3. So 1, 2, 3 goes through that point. And when x is equal to 0, y is equal to 2. 1, 2. So it goes through this point. Now, since this is strictly less than right here, the boundary is not going to be included in the solution set. So I want to graph the boundary with a dotted line. This shows that the boundary is not part of the solution set. Now, the graph of this linear inequality is either above this line or below this line. And if it is above the line, then all the points above the line work, and none of the points below the line work. If it's below the line, then all the points there work, and none of the ones above it work. So all we have to do is choose any point whatsoever that's not on that boundary line and check it in the original inequality. A good test point when it doesn't lie on the boundary line is the origin. So let's test the origin, 0, 0, in the original inequality. 0 plus 0 less than 6. The question is that a true statement? Is 0 less than 6? The answer is yes, that's a true statement. So this point right here satisfies this inequality. It lies below the boundary line, so all the points below the boundary line are solutions to that inequality. So to graph a linear inequality in two variables, we replace the inequality symbol with an equal sign. We graph that line with a dotted line if it's not included in the solution set, and a solid line if it is. Then we test any point whatsoever that we want that lies off that boundary line. Here's another example. Y greater than or equal to 2x minus 1. Let's graph this equation right here. Let's see, it has a y-intercept of negative 1. So it goes through negative 1 here and has a slope of 2. So if I go up 1, 2, and over 1, I'm back on the graph. Now, the inequality symbol is greater than or equal to, so this is part of the solution set. So that is, the boundary line is part of the solution set, so I'll graph it with a straight line. Again, the origin is not on the boundary line, so I'll use it in the original inequality. So let's test 0, 0 in here, and when I do that, I end up with 0 greater than or equal to 0 minus 1, 0 greater than or equal to negative 1, and again, I get a true statement. So since that's a true statement, here's my test point right here. It lies above this boundary. All the other points above the boundary must be solutions also. Now, it wouldn't matter whether I get a true statement or a false statement here. If I get a false statement, it just means that I'm on the wrong side of the boundary, and I go to the other side of the boundary and shade that in. So either way, we only need to test one point. True statement, we're on the correct side of the boundary. False statement, we go to the other side of the boundary to find our solution set.